Okay, first I'll draw one. It'll be easy. It has become thick. Okay, there's a shape of the rope at t equals 0. What we can put it here, no? We'll take some several points. We'll designate some points here. There's a 1, 2, 3. 24 points are there. What are those 24 points? The 24 points. Let me take the. It's a reference line. There are some. If you look at the some foreign author books, no, they are trying to generate so many things to explain the basic concept. Then they started exploring numericals. Huh? If you look at our books, no, straight away they jump to the half-page theory, then immediately start numericals. So without giving concrete idea, straight away when you are directly taken to the numericals, definitely find very difficult. No, first you give diagrams, explain it very systematically, give so many examples. Why I'm not getting this is from here. Let me draw it. Taking more time. Just these are reference lines which will help us to understand things very clearly. Otherwise, just only one diagram will not help you anything. So what are dots? We can take any number of points. Okay, let's take few selected. Some 25 points I picked up. How do they move at different instants of time? That is what our primary question. Okay, these are things. So this is at how the wave is moving towards right. Let's assume that the wave is propagating towards right. How the points on a rope are moving. I brought magnified one. We have a supporting equations. What are the supporting equations? At t equal to 0, this is the shape of the rope at t equals 0. A sine kx minus omega. Later on, I'll show you how to for different shape. At t equals 0, at t equals 0, there's the shape of the rope. Okay, this is what you are saying is as t equal to 0. This is the thing. And how the wave is moving towards right. Agree this. Then we have equations minus v into slope. Slope is nothing but dy by dx. So dy by dx is nothing but slope. And what we have, the points on a rope, they're executing SHM. And what is the wave speed? Wave speed is quotient of t by quotient y. That already we know, and the wave is propagated towards side. Okay, let me ask you. This is shape of the, what is this? Yx graph it is. This amplitude. At t equals 0, you can see the shape of the rope like this. So this is the rope. At t equals 0, this will be the shape of the rope. Can we say which points in what direction they're moving? So what are the points? The points are here. To learn this, I'm picking up some several points. Not many, some specific points. Let me take it. Okay, let me give the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a maximum displacement already. So now there's a point. Now can we say that at this instant of time, how the various points on a rope are moving? I'll take help of our old discussion is this particular thing. With the help of this, we are going to predict it. Okay, let's come for point 1. The wave is moving towards right. So we are going to put positive. What is the slope? Slope will be positive. So how if VP positive means moving up, VP negative means moving downward. There's a sign convention. What is the sign convention? Anything towards right, positive, towards left, negative. Anything vertically up, positive, vertically down, negative. Velocity, axle, what will be that? So VP, if I get positive means what does it mean? This particular wave is moving up. Okay, I agree this. Then what about next point? Okay, this point also. I'm asking you to concentrate on this. All of you, just there's a very fundamental. Today, I think your chapter will get over once you understand this. Rest of everything mathematics. Okay, now in what direction this point will be moving? You come for this. V is the wave speed. Slope S, the slope of this is more. This will be less. No, all of you know slope tangent. If I draw a tangent, take scale, draw a tangent, then measure that angle, it will be less. No, so but what is the velocity of this? Will be upward only. So this will be moving upward. This is the point 2. Then what about next point 3? What is the slope of this 0? What is the state of this particular point? It should be at rest. Dy by dx 0, slope 0. So what is the state of point? Point 3 will be at rest. So how the various points? The 1, 2, and this is 3. Keep an eye on the number. Let's get into. No, what is it? 3 will be attached. What about 4? Anybody? Look at this 4. V is positive. What is the slope? Slope is negative. No, negative of negative will be positive. Oh, sorry. Once again, I'll come back. I think I'm some slope. No, and now what is that one? V is positive. Slope is positive. Negative it will come, so it will be moving down. No? I think I'm some. Then 2 will be downward. The reason for that, V is positive. The wave is moving towards right. For every all point, the wave is moving towards right. The disturbance will propagate towards right. Then look at the slope. Slope here, positive, positive. Slope is positive. Then velocity of particle negative. Negative means should be downward convention. 1 and 2 are moving downward. All these points on a rope, they'll be moving down. What about 3? 3 will be at rest. At that instant, at t equals 0, 3 will be at rest. Point 3 on a rope will be at rest. What about 4? Negative slope, negative of negative, positive. So how the point on a rope, it will be moving up. So 4, 5, 6, what happened? They'll be moving up. What about 7? Slope at 7 will be 0. So 3 and 7 will be at rest. What about 8, 9, 10? Slope will be positive. Velocity of particle will be negative. So how this will be? This will be moving down. Getting some idea? At that instant, so tell me like at t equals 0, which all points are on a rope are attached? 3, 7, 11, 15, 19, and 23, they are at rest. Because see, I have to show they will move perpendicular to the rope. No, I took it this one. So this is what time? This is at t equal to 0. Let's go for next interval of time. What is the next interval of time? T is equal to t by 4, I'll write it. Or t by 8 if you want. T equal to t by 8. So what is the t by 4 in SHM? Time taken by the particle to move from mean to extreme. No, t by 8, what will happen to this particle? Will not reach mean, will be somewhere here. So the next part of the thing is two lines is needed. I'll go for t by 4. It'll be easy for me. Otherwise, we have to draw so many things. Huh? T by 4. T by 4 means time taken by the particle to move from mean to extreme or extreme to mean. So where do this one? The one will be somewhere here. Let me put dots so that will be easy for me to. Where it went wrong. Oh, dot should be here. Huh? Oh, yeah. Okay, now the rope will be. Tell me like the one where the one was somewhere here, no? No, how the one? Okay, we'll go for one will be a test. The two what happen will be moving down. Okay, this will be and this will be a test. This will be moving up. This will be attached. So now the one which was at main position moving down, what will be the state of it? It will come to the lower extreme. This again, what is this? This is a rope every time, again and again. When you see sine graph, it's a rope only. Okay, now look at this particular point. So the 4, look at the 5. The 5 which is at, I'll only represent the mean positions because the points are needed. No, what are the points? That one. So this is the 1, 3, 5, 7, 9, 11, 13. Okay, let's at least concentrate on the some specific points, if not all. Okay, look at the point on a rope on 1. How would it move? It will not move horizontally, it move vertically down. T equal to T by 4. At T equal to T by 2. It will be at this position. Okay, next, I'm going for the next interval of time. This will be the shape of the rope at T equal to 3T by 4 or T by 2. This is T equal to T by 2. Again, we are interested in that specific points. Okay, this point. No, in what direction the wave is propagating towards, right? Red color we use, no? Now you can see this. How is this point? According to the formula, what is the formula? Vp equal to minus v into slope. Okay, like the point 1. There's a point 1, 2, 3, 4, 5, 6, 1. Okay, sorry. 3, 5, 7, 9, 11, 13, 15. Can you say anybody about point 1, how it is moving? Wave speed is positive, slope is negative, so it should be moving up. This will be moving up. This will be moving up. And what about this one? This will be moving down. How do you can say I have mathematical equation? From there I'm saying it. Okay, this is about T equal. T equal to 3T by 4. Oh, we have to go for next page. Huh? Again, we have to plot. Okay, so same thing. Let me continue. Or I can copy it, no? Part of it. Not possible. So the vertical lines to tell you the position of a particle. We have. Okay, this is. Okay, let's come for the thing. So this will be at extreme. Let me plot another one also. It'll be easy for us. We'll finish off this. There's a line. Just after class, no, when you forget a time, you just look at and analyze it. That will be sufficient. Almost this chapter will get over for you. This is a very core part of the thing, that one. Rest all mathematics. Anybody can, you know, sine, cos, what is there in that one? Okay, the wave is propagating like this. This is t equal to 3t by 4. T equal to t, the original thing. Okay, these are the points 1, 3, 5, 7, 9, 11, 15, 17, 19, 21. With any number I missed, 13, 15. Okay, how the points will be moving? We have this one. So this will be a test. This will be moving up. Directly. So on what basis we will predict in what direction they're moving? By using the formula, no, Vp equal to minus V into slope. So with that, at any given instant, how the various points on a rope are moving, we can predict. Okay, one oscillation. I am unable to show total one oscillation. In one oscillation, look at the point one of a rope. How do it will move? In one oscillation, our point on a rope. Let us start with mean position down. It will go down, then up, come to mean position, moving velocity upward, then upper extreme, then mean position. So like that in one oscillation, complete to and fro motion. And how the energy will flow horizontally. How the various points on a rope will move, just using this particular point, using this equation. So you want in what direction this particular point on a rope is moving at a given instant of time. Okay, that one, there you calculate a slope. You know in what direction wave is propagating. We'll get the velocity. Look at now, on either side of mean position, how the points on a rope will be moving. These points are yet to reach upper extreme, no? So they'll be moving up. These points already reach upper extreme, they're moving towards mean position. You can see. On either side of extreme point, how the points on a rope will be moving. They'll be moving opposite to each other. Will I agree? On either side of mean position, how the points will be moving in same direction. You see 4 and 6 moving up. 10 and 8, they're moving down. On either side of extreme, they'll move opposite. On either side of mean position, they'll be moving in same direction. There's a one simplest thing. Just remember this formula, it's over. Why all these things? So what is this YX graph? This is YX graph only. What is this? What you are plotting? YX graph. This is the now this one. So if you see in notebook YX graph, tell me what actually it represents. Anybody? I want you like a the conclusion. If you see YX graph, now what is the time? So what you're seeing YX graph at what at t equals 0. What actually it is? Anybody? What you are visualizing, you tell me. What you are seeing, you tell me. That is enough for me. Anybody wants to answer? What it is? Is it a graph or is it a rope? At t equals 0, is it a graph or is it a rope? Pretty sure it's a rope. Tell me, tell yourself 1,001 crore times, it's a rope, it's a rope, it's a rope. At what? At t equals 0. How the rope is, it is like this. So shall I say at t equals 0, the shape of the rope, it is like this. At t equal t by 4, the shape of the rope is like this. So what is YX graph? If you see YX graph at any time t, what it is? Shape of the rope at any time t. Getting the idea? Shape of the rope at any time t. So therefore, the YX graph at any time t, what it will give? It will give the shape of the rope at any time t. This is a very, very, very important conclusion. Very, very important also. So therefore, what is the conclusion I can make it? Let me write it here. The YX graph at any time t will give the shape of rope at that time. Finish sure. This is very important. The moment you see YS graph, so what's happening? Just giving the shape of the rope. If you know the rope shape, can you predict slope? You know enough dy by dx, and you know in what direction the wave is propagating. You can tell in what direction the points on a rope are moving. I think we are in one of the best position. No, now if you know, so sir, how to get the shape of the rope? Okay, you hold one end of the rope and you start moving your arm up and down. They will be forgetting. You ask your younger brother or elder brother or some sisters or somebody or your parents to take photograph of that, and also the time at which they have taken the snap photograph. Okay, at that instant you know shape of the rope, and you can tell at that instant in what direction the points on the rope are moving. Getting the idea? So you do get a question for like a snap photograph of a wave propagating. What do you mean by that? Just simple. Nowadays we have mobile, no? Very easy to take photograph. At that instant, at what instant of time you clicked your mobile, no? You took the snapshot. That is the time at which you are having a shape of the rope. Got the idea, no? So this is the meaning of this. Tell me like, what is the which point will have maximum? It's SHM, no? So zero point 0.5 should have maximum. Who will bring them back to equilibrium? You see, zero point 0.5 is at extreme. What makes it to come to mean position? What makes it to come to mean position? Who will? The tension. So there should be some restoring force, so a component of tension. So tension here we elect. The resultant of that will make it to move like this. So like that, they'll be executing SHM and the energy will be flowing like this. Points on a rope will be moving up and down. That's why they say transverse wave propagation. Why transverse mechanical wave? Because the points on a rope are responsible for flow of energy. Why transverse? They'll move vertically and the energy will flow horizontally. Got the idea, no? Okay, design. Now, similarly, a student plots YT graph, Y of T graph. Okay, now what we had is XT graph. No, let me go for YT graph. I think I have. Let me give separate. You'll get confused. A student plots YT graph. It's not a shape of the rope. No? Plus A minus A Y. This is T. T by 4. T by 2. 3T by 4. T 5T by 4. 3t by 2. This will be 2t, no? 7t by 4. Okay, student plots y of t graph. Of what? Of a point and a rope. What is this? What is yt graph? How the displacement of a point on a rope varies with the time is given by yt graph. So yt graph gives the displacement of a point of a point, not many points, so of a point with the time, with the time t, with respect to time. Okay, no. So therefore, shall we call this an yt graph give the displacement of a point on a rope with respect to time of only one point on a rope. So what is that point? Anything you can pick up. Point 1, point 2, point 3, point 4. Like this, we have took 25 points now for any one point. From yt graph, what we get? Time taken to complete one oscillation. Time period. We'll get amplitude. Okay, got this? So like this, what will happen? We can calculate the time taken by a point on a rope to complete one oscillation when a wave is propagating. Don't show V here. And here it's the maximum velocity. You know it's SHM. So here it's the maximum. Don't show V down here. It's of a one point. It's a graph now. It's not a shape of the rope. What is it? It's a graph. It's a curve. Not a shape of the rope. Am I right? Some point. So what is that point? So graph gives the displacement of a point on a rope, of a specific point on a rope. Specific, I'll write it, the one which you picked up. Specific point on a rope with respect to time t. So we do have that one. So now let's come for yx graph. Yx graph, what all things we can calculate. Now look at this at t equal to 0. Look at this one. Look at 0.199, how they are at mean position and moving in same direction. Shall I say they are having same phase? Go back to SHM. Go back to SHM. Or look at 5 and 13. So let me take the one which is moving up 0 phase at mean position. So as it moves up, what happened to phase from mean? Moves up phase will become 0, pi by 2, pi, 3 pi by 2, 2 pi. Can you recollect SHM phase? That one. Look at 5 and 13. They're having same phase, no? So how we define wavelength? Somewhat. Distance between 2 points on a rope that will have same phase. There is a wavelength. So from Yx graph, can I find out the wavelength? Yes, it is very easy. So the wavelength is what I'm going to get it. So why only you're calling this as wavelength? Okay, the distance between 2 points which will have same phase. So the same phase is this one. This is the lambda. No, sir. Even 13, 21 also are having same phase. Okay, write it. No problem. Tell me like which graph is having more information? Anybody answers? What all you can find out from bias graph? You know amplitude. Let me slowly introduce. Okay, this is the amplitude. Plus C, minus C. Am I right? So now in Yx graph, what all you can find out? You can find out the amplitude of a wave. You can find out the wavelength of a wave. You can find out the speed of any point on a wave. So we'll get lambda, A, and also speed of any point. In YT graph, time period will get it and amplitude will get it. Tell me like which will give better information, Yx graph or YT graph? I should not say Yx graph because on paper when you plot will become Yx graph. Which graph will give better information? The Yx graph. So from Yx graph we can find out the even time period also. For that what you should plot for one wave. Getting the idea? So in y-axis graph, we can predict in at a given instant of time which particular point on a rope in which direction they're moving, what is the acceleration of it. This one. So because what is the acceleration? What is the formula? A equal to minus omega square y. You know at what point it is. So you'll get the acceleration also. You know speed also. You can get the wavelength. You know the amplitude. So y-axis graph will give a better information for us than y-t graph. Got the idea? So now when you see y-axis graph, tell me what it is. Shape of the rope at any instant of time. The rope at that instant will be like this. Y-t graph, it's a curve, the y displacement of a particle varying with the time. Getting the idea now? Now, can we say phase of a given point as zero phase? Pi by 2, 3 pi by 2, like a pi, 3 pi by 2 pi. Okay, I think we have chemistry sir will be waiting. We'll wind up the class here. Okay, now you can read, think, analyze, watch everything. Tomorrow we'll start with the numericals straight away. So you have y-axis graph, y-t graph, wave propagation, everything. Just read, think once, you'll be in better position. Okay, thank you, all of you. So try to analyze all everything.